So the title of this talk is Conditional Logging Considered Harmful, and it's inspired by work at a few Equal Experts projects, the e-commerce platform in general in about 2011, Smart Steps in 2012, 2013, and most recently, the work we did at GDS earlier this year. So I think a lot of people are confused when I say conditional logging and what is conditional logging. So what conditional logging frameworks are, these are sort of the conditional logging frameworks in the Java world. So you've got the granddaddy of them all, log4j. You've got Java util logging, the sort of the standard one. There's logback, there's SLF4j, and there's commons logging. And these are sort of the standard logging frameworks in the Java world. There's ones in .NET that are somewhat similar. People have crazy wrappers around them in Scala, but they all form basically the same pattern, which, as you can guess from the title of this talk, I hate. And that is they're conditional. And by conditional, I mean you've got a bunch of different log levels, from severe to trace, or error to trace, or sometimes, like Java util logging, severe, warning, info, config, find, finer, finest, which is just a bunch of made-up stuff. But they all have the same idea, which is that basically the logging is sort of dial a yield. You can choose to show only the most severe messages or the most important messages, or you can sort of up it and show the least important messages. And it's conditional, which means that at log time, the framework decides if it's going to log your message for you or not. So logging is not harmful. I should get that out of the way right now. Logging is awesome. It's also often very useful. HTTP access logs are one of the most useful things on earth. Everybody should have more of them. But that conditional pattern is not useful. That conditional pattern is harmful, and I'm going to show you why. So the usual arguments people give as to why they should use a framework like this, there's generally three of them. The first is you can log the really high detailed stuff in development and only the important messages in production. In practice, people often don't do that. The other one is then when something unexpected happens in production, we can increase the log level sort of on the fly without re-releasing the code, and we'll get more log messages, and that will help us. And then the third is we can use that really detailed log output during development to do debugging. But actually, I think the real reason people use them is that they're there, and there's no real alternative. And it turns out that, with the exception of Java util logging, they were all more or less written by one guy. And the guy's name is Seki Gulku. And the reason he wrote them is that he was working on an IBM project way back in 1999. And that project, for whatever reason, they decided that they needed this sort of technology because they wanted a lot of log statements for debugging, but they didn't want to clutter them up in production. So most of these frameworks were written or stem from a code base that was in about 1999. Some of the open source ones were forked. Sun developed their own proprietary competitor to them in Java 1.4 just because they did. But it all sort of stems from the same idea. But the problem is that's closing in on 15 years ago now. And that project didn't use unit testing and didn't use agile development because it was an IBM project from 1999. And I would submit to you that these days, when we develop software, we don't use a lot of the best practices from massive IBM waterfall projects in 1999 because they didn't know what they were talking about. They arguably still don't, but that's another story. Anyways, they have those reasons. We can change the levels on the fly, and there's all these reasons why that will be helpful for us. But we live in a different world. We live in an agile world. We practice pervasive TDD. We have really great code coverage. So the first reason, you're going to log fine-grained stuff in development and only the important things in production. And the first problem with that is it's not the simplest thing that can possibly work. It's not the simplest thing that's responsible. Because when we develop code, we avoid functionality unless it's used in production or unless it helps you test. And of course, trace really fine-grained logging is neither of those things. And the second problem is that when something unexpected happens in production, this idea that you can increase the log output on the fly, well, you can, but there's this idea that it'll be helpful for you. And we have a term for that. It's called the YAGNI. You ain't going to need it. Or more particularly, in this case, you're going to need something else. Because the problem with this story is that you are guessing what you're going to need when something completely unexpected happens. And when you think about that, you have no idea what the completely unexpected thing is going to be, because if you did, it wouldn't be completely unexpected. So because you don't know what it's going to be, you have no bloody idea what you're going to need to help you diagnose it or help you fix it. So if something completely unexpected happens in production, you are in fact in big trouble. Because the trace level log statements you have there probably may or may not be what you need. But they're probably not, because you're guessing. And just like all the times we use Yagni in development, we don't guess, because more often than not, you guess wrong. So if you actually run into this, what you're going to have to do is probably push out another build really quickly with the log statements that you do need, because that's what everybody ends up doing. In which case, why make them conditional? The other thing you can do as it happens is there are dynamic bytecode instrumentation libraries like btrace, where you can actually connect to a running Java application and modify the bytecode on the fly and have it add some system.out.printlns. And if you're in really expensive land, that can get you out of some trouble. But either way, you're actually modifying once you know what the problem is, not beforehand. And the last one, the big one, we can use these log statements to help us debug while we're developing. I call shenanigans because it's 2014 and we do TDD, and instead we run our unit tests inside a debugger like grown-ups. But the big problem with this with all of these logging frameworks is the intended audience, which is mostly developers, or at the very least, kind of everybody. And that's really wrong. The actual intended audience for logging should be operations or DevOps. I don't think anybody here knows Martin Jackson, but he was the DevOps specialist on the last team I was on. And when it comes to treating your operations people right, my motto is very simple. Always treat your operations team like it's a huge guy covered in tattoos who's really good at judo. Because if you've met Martin, you'll know that at Equal Experts, that is actually what our operation teams are like some of the time. So basically, but more than that, more than just the frequent threats of horrible physical violence, it's also that they're the users of the applications that we write, or at least some of the user base. And they might be the most important users you'll ever have, because with enterprise software, your operations team are the users that turn the software on. And if they're not happy with it, it's very difficult to get it released. And we, over a few years and a few projects, have come to the conclusion that making your ops team search through a mound of unorganized debug log statements to find a few important things that they need is kind of like making them root through garbage. And they don't really like it. They'll put up with it if they have to, but it's not ideal, and they're never really thrilled about it. And they're much happier when you don't make that happen. So there are some really bad side effects to these in exchange for all of these values that we don't really need, you have to put up with a lot of stuff that's not very good. And to demonstrate this, I'll show you what a logger always looks like. If you've done any Java development, you've probably seen something like this peppered through your code all over the place. Private static final logger log equals some old thing to declare it. Pretty much the only things about this statement that aren't a massive problem is the type logger, the variable name, and the keywords private and final. So some real problems with this. Because it's a static variable, it doesn't work with dependency injection. So you can't mock it. Because you can't mock it, you can't test it. Even if you could, because it uses lookup from a static factory method, you still can't mock it. So they're basically impossible to test because of the staticness and the disrespect of continuous integration. And then even if you could mock it, you couldn't mock it in a thread-safe fashion. Because it's hard to test, the upshot, people almost never test their log statements. And now I'm sounding a bit pedantic. Test your log statements, but it can be done. And when you do, good things probably happen. But there are other problems with this as well. And the big one is this right here, which doesn't seem like much. But what that actually does is takes the name of the class, turns it into a string, and that string actually goes into the log message, which doesn't sound like too much, except that we're now leaking information about the internal structure of the application out into both the log file itself and, more importantly, into the configuration file for the log, which means if you refactor this, if you move this log statement to another class, you break your logging configuration files. Also, to properly configure your application, your ops team has to basically know what your class structure is to the point where they've almost read the source code, which is fine for open source projects because they just sort of assume that everybody's going to do that. But in enterprise software, it's not a great idea. So this basically leads to spaghetti code everywhere, static variables, service lookups, and useless debug code that doesn't support production. So now all of a sudden this slightly harmless logging statement is encouraging bad practices, hard to test, not working with dependency injection, leaking the internal structure of the app, and it's sometimes too configurable. And this is a real problem because not all logs are the same. And if you're using log4j or logback, someone can edit the configuration file and turn off your audit log, which is a real problem in enterprise software because audit logs are very much meant to not be turned off. Being able to turn off the audit log is a bug, straight up. And they're often too configurable, and they're not really consistent because each log statement is just sort of a one-off. You pass in a string, you kind of get out what you get out. They're basically just sort of stringly typed. And another thing that happens, and this is one that operations in practice almost always asks for, the first thing they'll ask for when you say we do logging is, well, what are all the log messages I might see, and what do I do when I get them? And the problem is you can't tell them because it's spread all over the place. So what would we like to have instead? Well, the first thing is that the intended audience is operations, not developers. Developers don't need this stuff. Developers should run their unit tests inside of a debugger to figure out how their program works. Or just write simpler code so it's really easy to figure out how your program works just by looking at it. Probably both of those things. But we want something that's easy to test because we want our operations staff to actually, as all users do, collaborate with us and actually tell us what they need to monitor the application, tell us what they need to maintain the application in production, and actually write user stories for us or with us. And then we want to play those against all the other user stories we've got. And so now that logging is a user story, we need to be able to test that it works. So we want something that's easy to test. We want something that's easy to refactor, because as with everything else, we want to refactor every part of this app when something completely unknown comes up, and we don't want to break anything when we do it. We want it to be consistent by default. We want the messages to all just sort of work out, be shaped the same way, have the same sorts of patterns. We want log files that are easy to read, and we want it to be easy to describe and document for our ops colleagues, basically. So a lot of those requirements come from this book, which all of you should read. It's called Release It. It's about 7 years old, but it's great. It's got a lot of different things in it besides logging about sort of what you do as your software is nearing production. But he's in particular got a chapter in here about what really usable log files look like. And as a hint, they look a lot more like, say, an HTTP access log, where everything's sort of fixed width and easy to parse, and a lot less like, say, Catalina.out, where everything's just chaos and basically garbage. So with those requirements in mind, over the last couple of projects that I was talking about, we kept coming to the same sort of pattern over and over again, and we distilled it to a sort of a Gang of Four style pattern. So we call it the OpsLogger pattern. And so basically, you have a logger that has a signature, and it takes a log message and some varargs. And the set of all the possible log messages you can emit is an enum. And each of those enums has a message code and a message. And so you pass in, and the message is a C-style format string. And so when you log it, you pass in the message and all the arguments that you want merged into the format string, and it'll merge it for you to create the log message. And so that looks like this. So here is, where's my cursor? Oh, up. There we go. So here is sort of the logger, and you take sort of a message and your object. And what we've done is we have made it very generic. There's a little bit of generic mumbo-jumbo there, but don't worry about it too much. What this means is that when you write your own log messages, you implement this enum, and you basically write this. So you have to write, unfortunately, this little bit, and you mostly have to write this because there's no abstract superclasses for Java enums. But you basically just sort of implement a 2-arg constructor, some final fields, and a couple of getters. And then here are all your log messages. And so each message has a code. The code is there so that you can easily parse the log file. Because those codes are unique, you can just run a really quick grep. And if you want to know if a success operation occurred, you just grep for the code GDS-000000, because 0 means it works in usual output codes. And if you find that, you know that's what you found. Also, because the format string is right here, it's really easy to grab this as well if you wanted to, because you can just run a regex over this. You've got all the information you need to do a regex anyway. But the key is that then in our code that's actually doing the logging, you inject here a generic instance of that OpsLogger, and you store it, and then when we do the logging, you just pass in the enum and the extra arguments, and it fills in everything for you. And so there's a lot of different sort of advantages to this. One is, of course, our IDE can tell us which log messages are being used and which log messages aren't being used. It's really easy to reformat. If you happen to need to log one message from two different places, you definitely get the right string. So what happened was that GDS, we did this pattern for kind of the third or fourth time, but because GDS is awesome, they release all their code in open source, and so the application that we wrote was released under an MIT license. And so what we've actually done is we took the part of it that was the logging platform, and we're just sort of splitting it out into a separate open source application and making it so it's reusable just as a library in its own right. So we've added some test support. And so what happens now is we've got a really nice mocking. So the class that mocks test, we have a mock factory that builds a mock for a logger for you, but it's not just a regular test double, because what it doesn't do is actually log anything everywhere, but it does verify that all the arguments work out correctly and match the format string. So it does the formatting for you, constructs the whole log message, and then throws it away. So it's really easy to mock stuff. And if you want to see that this message was logged, but no other message was logged, it's basically just Mockito at this point. So it's very, very easy to test. But also, we provide some contract tests for the other thing. And just by sort of a few lines, and it's slightly voodoo, but we've got a superclass here for the tests. And when you run all these tests, what you find is, come on, there we go. We test each possible log message, and we test things for you that, like, the code is unique. The code is not null, the code is not empty, the message isn't empty, all of that sort of thing. So we do just sort of a lot of testing on all the enums and all the sort of the really basic cases where you could have sort of a slip finger mistype something. We just sort of check all that for you, really straightforward. But the coolest thing that I have forgotten to open, which I will do right now, is that because these enums are there and you can browse, you can very easily, using reflection, browse this. We wrote a quick task that at runtime is part of a Gradle script, and with about kind of like 3 lines of Gradle, which I will show you in a second. Hold on a second. I need Gradle, the sample usage. So by just sort of adding this little section right here to your build, what we get from that is we get automatically generated. Come on, move up. Oh, it's left. How do I get over there? Hold on. Where is it? Oh, hold on a second. Okay. We get, I'm having a multi-monitor failure, but basically it can generate a text file of all the possible log messages that the application can actually possibly emit at all. So for each one, you get the codes and you get the format string. So it makes it really, really easy to generate wiki documentation. And in fact, it's very easy. Not easy to show it, apparently, because I suck. But it's very easy to, come on, work, to actually include this as, say, include this as an artifact with a Jenkins build. So it'll just run through and generate all the things, and you just have it right there so that your ops code, your ops team can look at each particular build and see what's there and exactly what they need. So it is not quite done yet, but we're working on it. And so the output looks a little something like this. So you get sort of timestamp, code, message, etc. So the particular thing about this library is it's very opinionated. You always get the same sort of format. Timestamp is always UTC because log messages should always be UTC. Time zones are just a horrible idea in this case. And you always have the code. The code makes it very easy to parse, very easy to check stuff. The format string is there giving you kind of whatever information you actually need. The message is at the end because it's variable width and it just makes it easier to find things. So this is reasonably easy to look through as a human being and find something if you're looking for it. It's also easy for a machine to parse. In this book, the author actually, Michael Nygaard, recommends actually making things fixed width instead of comma delimited, which means sort of space padding everything. We're thinking about doing that. Maybe we will, maybe we won't. But either way, the idea of having things relatively fixed width all the way across does seem like a really good idea. It makes it much easier to spot stuff. As we were talking about before, you can easily use the format strings from the documentation to build a regex if you do actually need to determine how many records got published in a successful run. So basically, GDS paid us to do this. We're turning it into an open source library. It's on GitHub right now, but not yet publicly visible because we want to patch it up. But it will be an open source project. It will be Apache 2. There's some things still to be done before we would use it in production. We want to finalize the naming. Microsoft is working on something that's somewhat similar to this. They call it semantic logging. We got to decide if we want to follow their example or do something a little bit different. We want to start using some log4j code because, ironically, there's some stuff that those other logging frameworks do really well. And that's things like log to a syslog daemon, log to a database, high performance asynchronous logging, all of that stuff sort of matters. So part of why the Apache 2 license is important, GDS originally MIT licensed this, and they were nice enough to send us a letter saying we could change the license. That will let us fork log4j code or combine them without any licensing issues, and we'll be able to produce something that does the best of both worlds in a very sort of straightforward fashion. We want to probably do some pluggable support for extra fields. Like if you're doing a web service, you'd probably want the username always in the log message. You would probably want possibly a correlation ID. And that's fine, but we'd want it so that it's always in every message as opposed to in some messages and not others. So it's still consistent for your application, but you can add certain things. And it would be pretty easy to make that so you'd look it up from an aspect, and the OpsLogger just knows how to look that up on every request. The big thing we still need to do is stack traces, because this idea of one-line log messages only doesn't work when you have a huge, massive stack trace. And that's the big remaining problem. So we've got a couple of options. One is replace the new lines with \n, so you get a huge, horrible 18K long line, and you have to go through and sort it out, but you could reverse that and see a line at a time if you wanted to read the stack trace. Some of the more attractive options we're thinking about is save it into a file and embed the file name in the message. If you're on AWS, you could save it to S3, embed that in the message, and there's some really cool options there where if you use the MD5 checksum of the stack trace as the file name, you get automatic deduplication, which saves you space. But more importantly, if you get the same stack trace happening over and over and over again, it'll have the same file name, so you can actually grep the file to determine how often a particular exception is happening really, really cheaply. So you'd probably do something like the message line, the class of the exception, and the MD5 of the stack trace sort of being in the line, and everything else is in the other file. Because you never really look at 100,000 of those, you look at one, right, to find out where it is. Or a JSON-based logging format. It's got some advantages, but it's really hard for human beings to read, and that's a real problem. So we're kind of trying to stay away from that because, yeah, it's horrible. It may be less horrible than all the other solutions, but I suspect it is, in fact, more horrible than all the other solutions. So we're trying to figure out stack traces, trying to figure out usability. It just needs a little bit of polish. But I think sooner rather than later, it will be at a spot where an EE internal project could use it. And we sort of aim to have that in a month or two, and then release it to the wider world in 3 or 4 months, and give people a better sort of more agile alternative to the stuff that's out there now. And that's it.